Hi, my name is Bjarke Gottfredsen and I represent MaxIQ. This is about the MaxIQ NASA HAB mission 2025. In this picture here you see our payload for the NASA HAB mission. It's a ride-share solution, so inside there is individual schools, which I'm gonna give a brief of during this presentation. The one could not fit inside, so that's mounted outside. And there's a lid on top that can be unscrewed if you want to get access. There's 4 screws like that with a knot inside that can be held in place with your finger. And then there is this side that faces the edge. They have 2 cameras and 3 power connections, which I'm also gonna go through. The ride-share are using this, we call them spines, these 2 panels, where the individual sub-payload is plugged into. They are powered across, so the main battery power is connected to this side, and then the power is led to the other side. Each of the individual payload have its own power supply. So they each provided up to 500 milliamp 2 times, so like an amp in total, 3.3 volts. The input is tolerated from 5 to 50 volts, and the input terminals here are polarity tolerant, so plus and minus can be connected to any of those. We kind of like expect a 28 volt input. The batteries are greater for that, and that's what we are tested for here in our long-term testing. The structure is printed in 10mm 3D PLA. There's a structure here where you can see the 2 elements, the 2 3D printed elements, and they're bolted together as I mentioned before. We did a G-force test, so the way it works is that we have mounted the payload on this wooden structure with 4 screws, and we have then loaded 4 kilo of filament on top of it on the weakest angle, and if that lasts, that means it can sustain the G-force that it have to suffer under the flight. And when it has to be mounted, there is 6 counterbore mounting holes with a dimension as provided here. The important part is that there is 2 cameras, and that side where the camera is facing, that also have to face the edge. So it has a view of the night sky when it flies. The screws are provided in case that you don't have the good enough screws for the mounting holes that we have here. The power connection, as mentioned before, there is 3 power inputs. Actually, there's 4. There is the big thumb screw terminals here, where plus or minus can be connected on any of the red and blue, sorry, red and black connector. Then there's banana plugs. That's what I'm using when I'm testing from our power supply, but of course they can still be used here. And then there's a small screw terminal. There's actually 2 of them. There's one on the other side also, and any of the 4 terminals can be used to power up the solution. As I said here, I put in A and B at each of the terminal to indicate that doesn't really matter with plus and minus. The power that comes in is going through a rectifier bridge before it's going to the rest of the solution. Then I'm going to talk a little bit about the individual payloads. This last section is not necessarily important in order to fly the mission, but it could be of interest just to see what is flying on this mission. So first up, we have Parklands Collins. They're here in Cape Town, South Africa. They have done 2 accelerometers on a prototype X chip, which they want to test against a standard MaxIQ accelerator, and a couple of other sensors is also available there. In the top right, you can see how much the individual boards are using of power. You sum them together, it doesn't give a fair representation of power, because the total is higher because of the conversion of power. Then we have Nipmuc, which is in Massachusetts in the US. They have 3 SparkFun sensors. They're mounted on our quick stemmer X-chip prototype boards. That means they just connect the small cables. There's no soldering needed for connecting these boards. They have standard 1-inch holes, so both Adafruit and SparkFun are using 1-inch separated holes, so they can just be mounted straight on the board like they're done here. It also features GPS to get an accurate idea about where we are. The GPS are mounted in the middle on all the boards that have GPS, so they have free view to the sky. The way they're mounted in our payload bay. Then we have Odyssey Academy. They're from Texas, and they are trying their first mission here and try to just get access to space. So they're using standard X chips for their flight. The same goes for International Leadership, also in Texas. They fly a few other chips then, so they're trying some other mission. And then we have Princeton Universities. They have 2 payloads. The first one here, they have a prototype chip they had developed themselves, so it's not a standard X chip, but they have developed a prototype chip that then can be being mounted in a board here. Then there's a special construction here. It's actually 2 institutions. The first one is CAMST, which is the 2 chips you see nearest me now here, the one weather chip, and the other is a CPU. That's the mission in total. Then the bottom board is actually a I2S microphone. In order to use that, they need to use our normal CWA core. So therefore, the 2 boards that say power only is actually just providing power. The core is then connected using the CWA. So you can see the top one here, they have a SD card, and there's one below that also similar have a SD card in. The board below have the I2C microphone, and they want to measure how sound dependent on the thickness of the atmosphere. So therefore, we have a microphone that's playing a tune according to their specification that sits here on the top layer in our new board, the Springbot here, which is it also have a buzzer built in, so therefore can play tunes. Then we have Princeton's other mission. They also feature a camera and also feature a GPS here. They have another prototype they have done, so this is their own prototype chip they have developed. Then we have Trinity. They're also looking for access to space. They work together in our ISS mission with Parklands College in Cape Town, South Africa, together with CAMST also in Cape Town. Then we have University of Cape Town. They have 2 rather big missions, both radiation sensors. So this is the first one where they're testing a radiation sensor. They need some more material to test this thing here, so therefore they have prototyped the board that clocked into the expansion type. So that's also going to be tested under the black tape here. The other mission is also a radiation sensor, and that sticks a little bit over the edge, but we have space for that. So that's facing up where we have more space in our volume. So then we have the Montana State University from Montana. They have done their mission board, their prototype board for the ISS, so they only have 2 connectors, and therefore don't click into our standard CWV that we use here for the NASA HAB. So therefore we connected it with a flexible flat cable, and we done a 3D box that then is mounted on the outside of the payloads, but it's screwed in solidly, so there should be no problem with that. And it feeds into the SD card similar to all the other projects in the mission. And finally, we have our own little project here. The only thing we're doing here is that we want to capture high definition photos as we fly, so therefore that's the only thing we're doing, and we use one of the control slots to do that. And as Scott Manley will say, fly safe.